Hello everyone. It has been a very long time since I created a video on my channel. I guess I have been busy with different life issues. Anyways, the purpose of this video is to share with you an example on how to implement a simple API and a simple server using Python and Flask for running geospatial functionality. We will basically pass a WGS84 coordinates and a buffer distance in kilometer to the server using the API, and we'll get back from the server a buffered polygon along with the point we passed as GeoJSON output. So first thing, if you are not familiar with the term API, the term stands for Application Programming Interface. An API can be defined as the mechanism of asking a server for specific data. The server can either retrieve the data from a database or it can make its own computations without the need of accessing a database. So we request from a server and the server responds to our request with the results. Request and respond are the verbs used to describe the workflow of an API. The response is returned to the client, which can be a mobile app, a web browser, or maybe a digital billboard. Digital billboards are the digital signs you can find on the street or inside shopping malls, displaying, for instance, updated weather information. There are two main types of APIs, REST and SOAP. Explaining the difference is out of the scope of what we are doing here, but I have to mention that we are building a REST API. An API is usually used by developers, including front-end developers and mobile native app developers. It is usually structured as a URL with parameters. The URL with parameters can be referred to as an API endpoint. This is a fake example of a fake URL or a fake API. As you can see, it's requesting two parameters. In real life, searching, for example, an address on Google Maps is an API call. Searching for a product on Amazon is an API call. And searching for content on Twitter or other social media is an API call as well. So how developers build APIs and servers to respond to requests from clients? Actually, there are different options of programming languages and frameworks. The two common examples are Node.js with Express and Python with Flask. Java, PHP, and .NET can also be used with other frameworks to do so. In this video, we will use Python and Flask. Here, Python is the programming language and Flask is the framework. The Flask framework makes it much easier to create a server and an API or more than one API in Python by writing less code compared to doing everything in Python natively. I'm not going to explain details on how to use Flask in this video. We will focus more on the whole concept of how to integrate geospatial functionality in an API endpoint implementation. It is worth mentioning that Flask can respond or render data from a server as HTML or JSON or other formats such as XML. Okay, now I have placed all the code you need to follow along on my GitHub account. You can find the link on the video's description. First thing, it is better to create a separate environment on our machine. Your computer might have other installed packages for other applications, and by packages I mean Python packages. Having a separate environment is used to avoid conflicts between packages for different applications. This in general is a good practice because you might have two applications on your machine using two different versions of one specific package, for instance. I have Python 3 installed on my Mac, and right now I'm under the Documents folder. Okay, so as you can see, I have the Geo app. So this is the code that was downloaded from GitHub. To create the environment, you can type Python 3-m-venv. And you can call it whatever you want. So I'm gonna call it Geo app env. Okay. All right. The ./ here means that creating the environment in the same path, which is documents. So now let me type ls, and as you can see, it created the environment folder here. So in Python, the venv package is used to install separate environments for your applications. By the way, this command runs on Mac and Linux environments, such as Ubuntu. I believe it is the same on Windows, but if it doesn't work and you're using Windows, you can double check on Google. Now, if you want to activate the environment, you can type source geo app environment bin activate. If you are a Windows user, you can type this command. So you can see right now we're in the environment. So whatever packages we install on this environment should be different from the regular prompt or from other environments on the same machine. Just to let you know, you can type deactivate at any time to go back to your regular prompt and exit the development environment here. I'll go back to the environment. Okay, now before I install the packages that we need for this application, let me show you the path on where these packages should be installed. ls geoapp environment lib python 37 site packages, right? So this is the path. So as you can see, pip is already there, but our packages are not there yet. Okay, now we can use pip to install all the required packages that we need. So to do that, we can type pip install r geo app. So right now we're going to the working folder, and there is the requirements.txt. Okay, so this file requirements.txt basically has all the packages that we need to install to build our app. So this command basically will install all the packages listed under the requirements.txt. I'll click enter. Okay, so now it's installing everything that we have. Okay, now let's double check everything is installed under the same path that I mentioned, site packages. Okay, so we can see Flask is installed, GeoJSON is installed, Shapely is installed. These are the only 3 packages that I need to build this app. Okay, let me clear everything here. Okay, right now we're inside the environment. Let's navigate to the working folder. So it's geo app. Okay, let us confirm here. Okay, so we're under the geo app. Now let me type ls. So as you can see, there's a subfolder called app, and there's the requirements.txt file that we used before to install the packages we need for this app. I have Visual Studio Code installed on my machine. So if I type code dot here, what happens, it will open Visual Studio Code on this specific path. Okay, so this is the requirements.txt file, and as you can see, there's Shapely, GeoJSON, and Flask. So I'm using Flask to build a server and to respond to API calls. I'm using Shapely to invoke the geospatial functionality, and I'm using GeoJSON to create a GeoJSON response, and Flask will send it back to the client. Okay, under the apps folder, you can see main.py. This is like the entry file of our server. Okay, so let me close this. Okay, it's better now. So as you can see, the first 3 lines are basically imports. So from Flask, we're importing the Flask class. We're importing 3 different functions: render template, JSONify, and request. And Shapely package has a geometry module, and under the geometry module, there is the point class, and there is a mapping function. And from GeoJSON, I'm importing point class, polygon class, feature class, and feature collection class. If you notice something here, both Shapely and GeoJSON have point classes. So to avoid errors in the code, I created aliases for both. So for the point class from Shapely, I gave it an alias of Shapely point. And from GeoJSON, I call it GeoJ point. And I give another alias for GeoJ polygon. Next, this is actually how simply it is to create a server using Flask. I will talk later about this line of code. Now let's continue. Flask uses decorators in Python for emphasizing the routes. Routes are basically what is written after the site name /. In this example, if you type localhost port forward slash or localhost port forward slash index or localhost port forward slash home, it will render the output from this function. The rendering here is not related to the video, but I just want to show you how to render HTML easily with Flask. So this function, render template, the one we imported here, basically what it does, it will look for a subfolder under the app folder called templates, and inside it, it will search for the file given, which is index.html. So if I click here, this is a very basic HTML file. Now let's go back to the code. So now this is the geospatial function or the geospatial API. It's called buffer point. Now when you look into the route, this means that if you type localhost port forward slash buffer point plus the query string, this function will be activated. So the query string will contain three parameters: longitude, latitude, and buffer distance. We use the request function from Flask to get the values of these parameters. We can see this on these lines, getting the values of the three parameters: longitude, latitude, and buffer distance. Now, we need to check if the given values for longitude, latitude, and buffer distance are valid. Error response is a dictionary here, so we will use it to generate the error and then to convert it to a JSON format for the response. The error will be rendered on the browser so the developer can see it and understand the problem on how he or she made the error on one of the parameters. So let me explain it for longitude. And before I do that, I want to mention that I should have used a try except block instead of the if else block. Sorry for that. And this is also the same issue for validating latitude and validating the buffer distance. The code on GitHub is updated with try except blocks for the three parameters. Okay, Flask gets parameters in string format. So in the try block, I'm checking if the given longitude string is numeric. Otherwise, what we're doing here is adding two keys for the error response dictionary and explaining the problem. And then we're returning the dictionary, but we pass it to a function called JSONify, and this function was imported also above in the code. And basically what it does, it converts the dictionary into a JSON format. Okay, now it's a good time actually to go back and explain what does this line mean. So here, Flask by default sort the keys given in JSON or in a dictionary that is converted to JSON for the response. So we don't want to do that. So if I go back here, so you see here longitude error, value given. So this is the correct order. But let's say, for example, that we want this key to appear first in the response before the longitude. So in other words, we are disabling Flask's default alphabetical ordering. Okay, now let's move to the next check. So basically what I'm doing here is checking if the longitude value is less than -180 or bigger than 180, which means it's out of range. In this case, I will return this error. And this is the same actually for latitude. As you can see, for latitude, the range is from -90 to 90. And for the buffer distance, so I'm limiting between 0.001 kilometer, which means it's 1 meter, up to 100 kilometers. If it's more than that, then I'm just limiting this API not to do anything. Okay, now let's continue. All right. Okay, so in this line of code, what I'm doing is I'm creating a shapely point by passing the longitude and the latitude. I've also added some documentation to help you understand what's going on. So on line 80, what I'm doing here is I'm creating a buffer. So this is a polygon. And basically, under shapely, the point object, there is a method called buffer, and I'm passing the buffer distance divided by 111. So why am I doing this? The reason is that Shapely is expecting the buffer distance in degrees, not in kilometers. So this is roughly how many kilometers in 1 degree. And this is specifically the conversion closer to the equator. It is different if you move away from the equator, but for the sake of simplification, we're just using this number. Now on line 83, what I'm doing here is using the mapping function to create a dictionary from the polygon object. And the reason I'm doing so is that the mapping function will create a dictionary and one of the keys will be called coordinates, and I need these coordinates so I can create the GeoJSON object using the GeoJSON package. So here, I'm just getting the coordinates and passing into this variable. So by the end of this line, we're done using Shapely, and now we're using the GeoJSON library. So for the GeoJSON library here, what I'm doing is basically creating two features. So one feature will be the point given, and another feature, which is the polygon created by Shapely. So as you can see in part one, what I'm doing is basically creating a GeoJSON feature using GeoJSON point by passing longitude and latitude. Then I'm adding some properties. So if you are not familiar with the GeoJSON format, properties have both attributes and symbology options for features. So here I'm giving it an attribute of name, and I just called it the API point. And for the attribute, I assigned the color red. This is the second feature, which is the buffer that was created using Shapely. And basically, I'm passing its coordinates here. So the polygon class under the GeoJSON package requires only coordinates. And once I create the polygon, I pass it to the feature class. So I have two features right now. I have one feature for a point and another feature for the polygon. And I'm passing some properties here. So this is an attribute name. And here, these are for symbology. So the stroke is the color of the boundary of the polygon, and I assign it to blue. The fill of the polygon is also blue, but the fill has an opacity of 30%. If you have any questions about properties or what is happening with the GeoJSON, you can post your questions in the comment section. Now, on line 100, what I'm doing here, I'm using the feature collection class, and basically what it needs is a list, and as you can see, I'm passing a list here of all the features that you need to add to the feature collection. Then at the end, I'm returning the feature collection as JSON format. So here what's happening, it's returning the feature collection in a GeoJSON format. And at the end here, we're just running the application. And if you see here, I'm passing a parameter called debug equal true. And basically what it does, it will allow you to see the changes on the server instantly without the need to restart the server. Okay, now let's run the application. So if I go here, before I do that, I need to double check that I'm using the environment. So the one that was selected was the regular environment, user bin Python. So I need to change it to this one here, geoapp-env. So if I click here, then right click, and I select run Python file in terminal. Okay, so if I click right there, so this is the URL. Let me just copy it. If I copy the URL for the local host. Okay, now I'm on Chrome. If I paste it here, I click enter. Okay, so now it's reading from the server, and I forgot to mention, this is the port number. So this is the default port for Flask. You can change it if you want to. So now let's try the API. So if I say buff distance. Okay, and remember, like when we pass parameters, we have to use the question mark first. So if I say, for example, longitude equal 101.7 and latitude is equal to 3.11 and buffer distance is equal to, say, 25 kilometers. Let me hit enter. Okay, let me just go back and make sure that I didn't make a mistake here. So the function name, so let's see, or the route maybe. Yeah, buffer point. Oh, sorry. So that's the error here. So that should be here. Buffer point. Okay. Okay, now we got it. So this is the output. So we have the feature collection, and this is the first feature, which is the point. And as you can see, this is what I called it in the code, API point. And this is the next one, which is the polygon. And at the end, you should see the properties. It is called the API point buffer. Okay, now I right click, hit save as, and you need to double check with the format. So instead of JSON, select all files and GeoJSON. Okay, so I'm just gonna save it under documents here and click save. So now let's test our result. So if you type geojson.io, so if I go to open, file, and I go to documents, this is the file, click open. It should make me somewhere next to Kuala Lumpur. Anyway, so this is the output. And as you notice, in GeoJSON, you can have points, polygons, and even lines in one file, which is different from shape files, for example, just to let you know. Now let's go back. So if I go to, for example, latitude, so instead of 3, let's make it 103. Click enter. Okay. So you can see here what it's saying. It says the latitude error, it's out of range from -90 to 90. Sorry for this. I mean, I don't know how to remove it, but you get the idea. And the value given in the API is this value. One last note is that you have to take care of errors while building APIs. Thank you for listening, and I hope you learned something here.